Hi, welcome back to my channel, Physics Form 5 KSSM. We continue Chapter 1, Forces and Motion 2 on topic 1.2, Resolution of Forces. In this video, I will discuss two learning standards. The first one is Describe Resolution of Forces. The second one is Solve Problems involving Resultant Force and Resolution of Forces. So for the first part, you need to define what is resolution of forces and describe situation involving resolution of forces. Look at this picture. You can see the person is pulling with a force at certain angle from horizontal, but the person here is moving horizontally. So we can say from here, direction of the force applied not the same as the direction of the motion of the object. But according to the Newton's second law, when acceleration of an object is to the right, the force that produces it also in the same direction. So you look at this picture also. To understand the situation, watch this video. This is tarik upih game. You can refer to the textbook. So this tarik upih game, you can see the force applied is inclined upwards. Ke atas, inclined upwards. But direction of motion of the person here is horizontally to the left. Why is the motion of the friend to the left while direction of the applied pulling force is inclined upwards? Just now we discussed it should be in the same direction, right? So from here we can say that the object will move to the left horizontally because there is a force that acts horizontally to the left. So based on the video, we can say that the inclined upward force that applied actually has a component which is horizontal that caused the object to move to the left. So in this case, we can say that the applied force can be divided to two components. The one which is horizontal and the other one is vertical. The process of resolving the applied force to two components, we call it a resolution of a force. So this is due to the pulling force having a horizontal component and vertical component. So the one that caused the motion horizontal is the horizontal component of the pulling force. Okay, let's define resolution of a force. Resolution of forces is the process of resolving. The word resolving means split to two parts, or in bahasa leraikan. Okay, resolving a force into two components which are perpendicular to each other. So we have two components, one is horizontal, one is vertical. Let's try to look at how the force is resolved. This is the pulling force that acts at angle theta from horizontal line. This arrow shows direction of the object moving to the right. Now what we do is resolve the applied force to two components, Fx and Fy. Horizontal component Fx and vertical component Fy. Okay, look at the angle here. This is angle theta. Okay, so you can see if here is theta, angle here is also theta. Let's label this one as ABCD. So you can see this is a rectangle. Okay, now we want to find the value of fx and fy. I'm using to use mathematical operation, trigonometry, to find the value of fx and fy. We draw a vector triangle. We form this one, a right angle triangle. This side is fy. So you can see this side is parallel to fy. Thus this side represent fy. And this side represent fx. So this is a right angle triangle. So you form a right angle triangle ACD. This side is the pulling force just now, or the applied force. Now we apply trigonometry by using cos and sine. For angle theta, fx is adjacent side. CD is opposite side. AC is hypotenuse side. Cos theta equals to adjacent divided by hypotenuse. Thus, fx divided by f. So from here, we can take fx as a title of the formula here. Thus, we get fx equals to f cos theta. Then we use sine theta. Sine theta is opposite divided by hypotenuse. Opposite divided by hypotenuse. Fy divided by f. Thus, we get Fy equals to f sine theta. So from here, we can say it's like a formula. If given the value of f and angle theta, you can substitute into this formula, then you get the value of fx and fy. Thus, we can say the horizontal component of the force can be calculated as fx equals to f cos theta. The vertical components, we can use the formula fy equals to f sine theta, provided that you are using this angle theta. Recall what we have discussed earlier in my last video, or my previous video. Resultant force for two forces perpendicular to each other. You still remember this picture? There are two forces acting perpendicular to the ball, 240 Newton and 180 Newton. If you want to determine a resultant force of the two forces, what you do? You can sketch a vector triangle, and the third side will be resultant force of the two forces. Because of this one is right angle triangle, so you can apply Pythagoras theorem. Then you get F equals to 300 Newton. And the angle here, theta, is 36.87. Let's say the same value of force and at the same angle from horizontal. Now we try to resolve it to two components. 300 Newton at the same angle 36.87. We try to calculate the horizontal component. Thus we get fx is f cos theta. Thus 300 cos 36.87 equals to 240 Newton. When we calculate the vertical component, Fy equals to f sine theta, we get 300 sine 36.87 degrees, we get 180 Newton. You can check again. Look at the value here. Same as this one. Okay. Does this a reverse process? Looks like a reverse process. So meaning we can apply the same formula. So the value of f is also equals to square root of horizontal component fx squared plus vertical component fy squared. Same as this one. Okay, so when you calculate for the value of fx and fy, you can check your answer by using this formula, whether your answer is correct or not. If you substitute fx and fy here, you calculate, you must get the answer here 300 Newton. Okay. Okay, let's discuss situation involving resolution of forces. You can refer to this one in your textbook, activity 1.5. The first situation is force applied at certain angle from the ground or from horizontal line. Aim to resolve a force into two components for an object moving in a direction not parallel to the direction of the force. So this is the force applied. The lady is pushing the mop towards the ground. Look at the direction. Angle of the force applied from the horizontal line, this broken line, is 60 degrees. Pushing force F is 32 Newton. We try to resolve the force to two components, Fx, the horizontal component, and Fy, the vertical component. Why do you think direction is in this way? If you want to know which direction you should use, you should draw Fx and Fy, look at the applied force. Applied force is acting at this point out from this point. Downwards, incline downwards. Thus, what happens to the component also will follow the direction. Okay, you can see this one is the hand of the lady, the lady's hand. Okay, so the applied force is coming out from this point, meaning the component also must be the same. It's also coming out from this hand, from the lady's hand, towards the left, and this one to the right. Okay, and it is perpendicular to each other. This one is downward, Fy. Okay. Now we want to calculate. We draw a vector triangle. So this one become Fx, and the vertical side will become Fy. We will draw out, it form a right angle triangle. Then we can use the formula. Horizontal component Fx equals to F cos theta. Thus 32 cos 60. And then the vertical component Fy equals to F sine theta. Thus equals to 21.7 Newton. If you still cannot understand why Fx we calculate this way and Fy this way, you can go back to the formula of trigonometry. Find the value of sine 60 equals to what? Cos 60 equals to what? Then you can also get the answer. Okay, so this one is the horizontal component and vertical component. The horizontal component will cause the mop to be pushed forward horizontally. The vertical component causes the mop to press on the ground. Okay. Okay, number 2, force applied at certain angle on inclined plane. Look at this boy sliding down the slider. In this case, we assume the slider is smooth slider. means there's no friction. The boy slide down due to the weight of the boy. As you can see, direction of the boy slide down is parallel to the inclined plane, meaning the force that caused the boy to slide down must be parallel to the plane component of force. As you can see, the only force that acts on the boy now is weight of the boy. So we can say now, weight of the boy can be resolved to two components. The component parallel to the plane and the component perpendicular to the plane. If you draw a free body diagram that acts on the boy, there must be normal reaction force perpendicular to the plane up here. Okay, so now I just draw the component of weights for resolution. So we have component of weight parallel to the plane and component of weight perpendicular to the plane. So in this case, the force that caused the boy to slide down is the parallel component of weight. Let's say we draw a triangle, a vector triangle. The purple color here, this one represents the component which is perpendicular to the plane. As I draw here, parallel to this one. And this one is the component of weight which is parallel to the plane. Now I have one right angle triangle. Now we draw out. We get this triangle. The angle here is 50. By using mathematics, I hope you know, this angle also is 50. Thus, we get angle here is 50. So we can label the component parallel to the plane, Wx, component perpendicular to the plane, Wy. We use W because it comes from weight, W here. Okay. Now we try to find Wx and Wy. We apply the same concept of trigonometry, sine theta and cos theta. If you use the formula of sine 50, you will get Wx divided by W. Thus, we get Wx equals to W sine theta. You substitute the value of W and angles, you get 300 sine 50 equals to 229.8 Newton. For the perpendicular component, Wy, this is at the adjacent side. So we use cos theta or cos 50. Cos 50 equals to Wy divided by W. Thus, we get Wy equals to W cos theta, or 300 cos 50. Thus, the answer is 192.8 Newton. So, you can use trigonometry formula again if you still cannot get Y. For Wx, we use F or W sine theta. For Wy, we use W cos theta. Okay, so just refer to this triangle. This is a right angle triangle. So we can say that in this case, for the inclined plane case, the weight can be resolved to two components perpendicular to each other. Component which is parallel to the plane, Wx, and component which is perpendicular to the plane, Wy. So which one is involved in the motion when the boy slides down the plane? You can see direction parallel to the slider, meaning the force that involved in the motion is the component that is parallel to the plane. Now we try to solve problems involving resultant force and resolution of forces. Look at example 1. Figure shows a wooden block being pulled by force T that inclines at angle of 30 degrees above the horizontal surface. Table 1.5 shows the magnitudes of forces acting on the block. So this diagram actually shows free body diagram of the wooden block. As you can see, the R, W, and FR are already vertical or horizontal. But there's a force T which is inclined at angle 30 degrees from horizontal. So what we do, we need to resolve force T to two components, horizontal components and vertical components. The horizontal part is Tx, the vertical part is Ty. You can look at here, given also the other values of W, R, and FR. Horizontal component for T is T cos theta. Angle theta is 30. Thus, we substitute 36 cos 30 equals to 31.18 Newton. Vertical component is T sin theta. So 36 sine 30, we get 18 Newton. So we have the component of Tx and Ty. Now we want to solve the second question. Determine the magnitude and direction of resultant force acting on the block. Okay, you can see the forces that act on the block just now. We already resolved T to two components, Tx and Ty. Thus, we can write all the forces that act on the block like this. Okay, so based on this, you can see all the forces are already vertical or horizontal. Now we can calculate resultant force. The horizontal resultant force will cause the object to move horizontally to the right. So the resultant force to the right, we put it as Fx equals to, we take direction to the right as positive, thus resultant force equals to Tx minus Fr. Thus we get 31.18 minus 20. Tr is given, or Fr is given, 20 Newton. The value of Tx calculated from part A, so we get 11.18 Newton. Vertical part of the forces. The object or the wooden block just now is moving horizontally, meaning the vertical forces are balanced. Or we can just calculate vertical resultant force equals to Ty plus R. Why we need to plus here? Because they are in the same direction. And we assume direction upward as positive. Thus, Ty plus R minus W. Ty we have calculated in from part A, 18. The value of R is 6. W is 24. Thus, in the end, we get Fy equals to 0. So, resultant force for vertical forces are 0, meaning forces are balanced. Thus, the resultant force that acts on the wooden block, F, is only horizontal resultant force, which is 11.18 Newton that acts to the right. But see, what is acceleration? Remember the formula, F equals to ma. What is F? A resultant force, or a single force that produces acceleration. In this case, the resultant force we have calculated here is 11.18 Newton. Mass is given. Thus, we can calculate acceleration equals to F divided by m, or 11.18 divided by 2.4, 4.66 meters second to the power negative 2. So we get the answer required for this question. Second question, example 2. Figure shows a free body diagram of a block sliding down a smooth inclined plane. Sketch the component of weight of the block parallel to the inclined plane and perpendicular to the inclined plane. Determine resultant force acting on the block. Calculate acceleration of the block if its mass is 2.4 kilogram. Look at this diagram. The idea of stating smooth inclined plane here is to state that there's no friction on this plane, or the block will slide down due to component of weight of the block itself. Let's say this is direction of the block sliding down, parallel to the direction of the slider or inclined plane. Inclination angle 60 degrees. Okay, these are the components of force or component of weight parallel to the plane Wx, perpendicular to the plane Wy. Now we want to solve question 2b. Determine resultant force acting on the block. Okay. As you can see here, the block is moving down parallel to the plane. Thus, the component of force Wy does not affect the motion. Or we can say Wy and normal reaction are balanced. Wy equals to W cos theta, or W cos 60 equals to normal reaction 12 Newton. Wy equals to 12 Newton. So now resultant force is what? It's a force that causes acceleration or motion. So this one is the force that caused the motion. So resultant force equals to Wx, because there's no friction, there's no applied force. This is the only force that caused the block to slide down. So resultant force is Wx. How to find Wx? We have discussed before, Wx can be determined by using W sine theta. Angle of inclination here is 60, meaning here also is 60. So W sine 60, then we get 20.78 Newton. Now we want to calculate acceleration, meaning use the formula F equals to ma. Okay, F equals to 20.78 Newton. Mass given 2.4 kilogram. Thus, we can calculate acceleration A equals to F divided by m. This should be divided. Thus, equals to 20.78 divided by 2.4. And the answer is 8.66 meters second to the power -2.